This is 99% Invisible. I'm Roman Mars.
I'm going to tell you a story first about how a building got designed, a very unusual building in New York, the Citicorp Tower.
When it was built in 1977, Citicorp Center was, at 59 stories, the 7th tallest building in the world.
You know, I can still remember the first time I saw the Citicorp Center. As you exit the local 6 subway station at Lexington and 53rd in Midtown Manhattan, you're confronted by a sheer 915-foot building face shooting up right from your feet.
That's reporter Joel Werner.
With its gleaming facade of glass and steel and striking 45-degree angle crown, the Citicorp Center is truly one of the most spectacular skyscrapers on a skyline known for its spectacular skyscrapers. But really, it's the base of the building that takes your breath away. This massive 59-story skyscraper levitates mid-air, hovering 115 feet above the street corner.
At first glance, the building seems to violate the basic laws of physics.
When you look up, you look directly at the underside of the building corner. It overhangs the sidewalk. I mean, where you'd expect a column or even the grounds, instead there's nothing, just thin air.
Of course, the building isn't really levitating. It's propped up on stilts, which join the building at the midpoint of each side. It does not look sturdy, but it's got to be sturdy. It's got to be safe, or they wouldn't have built it this way. Right?
Yeah, well, that's the secret about this building. And it was literally a secret for nearly 2 decades after it was built. The Citicorp Center could very well have blown over in the wind.
What I wanted to know was, when was this building going to fall down?
The architect of the Citigroup Center was Hugh Stubbins, but most of the credit for this building is given to the chief structural engineer, William Lemessurier.
You laugh at me, but I did conceive it on a napkin at a Greek restaurant in Cambridge.
Lemessurier passed away in 2007. This is him giving a talk at MIT in 1995.
The whole problem was to build a building on a site that has a church in one corner.
St. Peter's Lutheran Church.
Crummy old building. It was the lowest point of Victorian architecture.
I don't think it was that bad.
St. Peter's sat at the corner of the lot, and when the church sold their land to Citicorp, it was on the condition that they build a new church in the exact same location. Beyond that, the company was free to build their skyscraper around the church and in the airspace above it. So a plan was hatched to float the building over the church, hence the stilts. And because the church was in the corner of the lot, Lemessurier put the stilts in, well, kind of a weird place.
You couldn't have columns in the corners where they ought to be in a conventional building, so they were moved to the middle.
Placing the columns at the midpoint of each side rather than in the corners made the building less stable. So, for additional support, Lemessurier designed a chevron bracing structure. Essentially, rows and rows of Vs, each 8 stories high, pointing down the middle of each building face, to where the supporting columns had been moved.
Actually, the architect wanted to keep the building simple in its skin because there was so much drama going on at the bottom and at the top anyway. He said, no, if you're going to have any diagonals, I don't ever want to see them.
So the chevron bracing structure was slipped under the skin of the building. It formed the Citicorp Center's skeleton. Now, one of the amazing things about this chevron bracing structure is that it's so lightweight that when the wind blows...
It is more dynamically excitable than a building that weighed twice as much.
In other words, it moves with the wind.
Which most people find really unsettling.
Understandably, right? So Lemessurier added something called a tuned mass damper.
The tuned mass damper is a mass of concrete which is 29 feet square and about 8 feet thick and weighs 400 tons. It is floated on pressurized oil bearings.
The device sits at the very top of the building and acts to steady the oscillations. It offsets the wind gusts.
So to recap, we have a 59-story tower floating on 115-foot stilts.
Stilts which are not in the corner where you'd expect them, but rather in the middle of each side of the base.
With a skeleton of beams shaped like Vs, which make it super light for a skyscraper.
And to stop it from swaying in the wind, there's a 400-ton block of concrete on the roof. Totally ingenious, really cutting-edge design. And Lemessurier's a pro, so in accordance with the New York City Building Code, he runs all kinds of mathematical models to make sure the building is going to hold up.
And everything seemed just fine until, as Lemessurier tells it, he got a phone call.
June 1978. I'm in my office. I got a call from a student at I do not know the school. I wish he would call me from the past. He never has. But anyway, he was a real student from New Jersey. I think he was an architectural student, and his teacher had given him this building to study and report on because it's unusual.
As Lemessurier tells it, this precocious college senior calls him up to ask how his building structure is going to cope with quartering winds.
An undergraduate student calling out the head of a world-renowned engineering firm on one of the most innovative skyscraper designs of its day.
Quartering winds, the winds that caught the student's attention, are those that hit the building on the corner, exerting pressure on two faces at once. Lemessurier's calculations on the perpendicular winds that hit the face of the building square on, seem to be fine. But as the story goes, the student raised the alarm about Citicorp Center being particularly vulnerable at its corners.
It turns out Lemessurier had never run the numbers on what quartering winds would do to the building, because normally buildings are strongest at their corners.
But this is no normal building. Remember what's going on here. Supporting columns shifted to the midpoint of each building face, the chevron bracing skeleton, and the unusually light mass of the building. Taken alone, no one of these design quirks should have presented a problem. But, as the student told Lemessurier, taken together, they left Citicorp Center particularly vulnerable to a wind striking the structure at its corners.
And when Lemessurier started to investigate the student's claims, he realized that the root of the problem had to do with a change that had been made to the original plans. It had to do with how the chevron bracing structure was fastened together. Lemessurier's plan originally called for the joints to be welded
with full penetration welds,
but the contractor had suggested using bolts instead.
Bethlehem Steel actually designed beautiful bolted connections for the forces that my people gave them.
It was a cost-saving measure. Lemessurier says that this change would have happened without his knowledge.
Given the wind load calculations Lemessurier's team had supplied, welding these Vs together was overkill. Run the math, and it looked like bolts would do just fine.
And bolts would have done just fine on pretty much any other building, except Citicorp Center had an Achilles heel on each of its four corners.
Lemessurier could now see what no one else had.
No one except for that pesky student from New Jersey.
And as Lemessurier started looking into the student's claims about these quartering winds, he realized the situation wasn't just bad.
It was a disaster waiting to happen.
The return period to failure was 16 years. Think about that.
Here's what that means. Lemessurier calculated the quartering wind velocities required to topple the Citicorp Center. He then matched these velocities to weather patterns to see how frequently, on average, winds strong enough to blow the building over occurred.
Lemessurier found that a storm strong enough to knock over the building hits New York City on average once every 55 years. But that's only if the tune mass damper is working.
The tune mass damper needs power to run, and if you're getting a huge storm, Lemessurier realised, it's not unlikely that the city could suffer a blackout.
Lemessurier ran the numbers again, this time imagining the damper without power.
And it was even worse.
Without the damper, a storm strong enough to topple Citicorp Center hits New York on average once every 16 years.
To put this another way, for each year the building was standing, there was about a 1 in 16 chance of a storm potent enough to take out the Citicorp Center.
This building is 915 feet high. If it failed, it would topple sideways in the wind, crashing into other Manhattan skyscrapers. A whole slew of buildings from Midtown to Central Park would fall like dominoes.
This thing is in real trouble.
This brand new skyscraper was on the verge of catastrophic failure.
But the imminent disaster wasn't the result of one glaring oversight. Rather, it was a sequence of minor issues. Let's remember how we got here. This building was on stilts because they had to build over the church.
And stilts placed at the corners would have been just fine, except the church was at the corner of the lot, so the stilts had to be in the middle of each face.
And that could have been A-OK. Except the offset stilts led Lemessurier to use an ultralight chevron bracing structure.
Which would have been perfectly adequate, except in the end, those chevron Vs were bolted, not welded together.
And even that could have been fine, except no one thought about how vulnerable this crazy design was to wind blowing at its corners.
No one except an anonymous college student.
Lemessurier went to Citicorp chairman Walter Wriston and told him they would need to open up the building and weld it back together.
And he said, how much is it going to cost? I don't think it's going to cost an awful lot. $1 million or $2 million? That's nothing for a building that costs $175 million, and if it falls down...
From here, Lemessurier and his team worked with the Citicorp bigwigs to coordinate emergency repairs on the building. With the help of the NYPD, they worked out an evacuation plan spanning a 10-block radius. They had 2,500 Red Cross volunteers on standby and 3 different weather services employed 24/7 to keep an eye on potential windstorms. They welded through the night and quit at daybreak, just as the building occupants returned to work.
But all this happened in secret over 3 months without telling anyone who worked there.
Which is the part of the story I kind of have a problem with. I mean, isn't this situation serious enough to warrant informing the building's tenants? My wife works in a skyscraper in Midtown Manhattan, and it's about informed consent. I'd want her to be able to make the judgment call about whether or not to go work in a faulty building, not to have it made for her.
Their thinking was a contingency plan was in place and ready to be invoked as soon as a storm strong enough to blow the building down was in striking distance of New York. Except...
there was a giant storm racing up the East Coast, Hurricane Ella. Lemessurier says the powers that be were just hours away from calling in the evacuation. But the hurricane veered into the Atlantic before it hit New York, and in the end, the public was never notified.
And I know what you're thinking. If only there was some kind of independent organization that serves the public's right to know, that might wonder why Citicorp Center was aglow with blowtorches all night, every night. Something like a newspaper. Except...
the New York Times was on strike.
Not only did the New York Times go on strike, but all the newspapers in New York went on strike until October. So we had a press blackout, and that was the greatest thing that ever happened.
So word never got out, and construction was finished.
And Citicorp Center has remained standing ever since, long enough to be renamed Citigroup Center and later 601 Lexington. And this whole thing remained a secret for almost 20 years.
In the early 90s, writer Joe Morgenstern overheard the story being told at a party. He interviewed Lemessurier and broke the story in The New Yorker in 1995.
Lemessurier went on to tell the story publicly, like he did at MIT, which is how we have him talking about this. And after the story got out, it was written up as a textbook case of good ethics in structural engineering. New York was spared a tremendous loss of life and the annihilation of its skyline, all because Bill Lemessurier was humble enough to give time to the inquiry of an undergraduate student.
Thank goodness for this uppity college senior and his thesis, and kudos to Bill Lemessurier, who, through his humility and heroism, saves the day.
And that's really the end of the story.
Except...
now wait a minute, there are a couple of more things here.
Let's take a step back and remember how this story starts.
I got a call from a student. He was a real student from New Jersey. I think he was an architectural student. And his teacher had given him this building to study. I do not know the school. I wish he would call me.
The way Lemessurier tells it, and how Joe Morgenstern told it in The New Yorker, the college student, the young hero of our story, was lost to history.
Okay, wait for it. Wait for this moment. It's a good one. Here it comes.
It would have been sometime in the early 90s. I remember being upstairs in my bedroom and had one of my sons. He was sort of hanging off me as I was trying to put him down to go to bed. And suddenly my husband, who had been downstairs, started yelling a little bit and saying, Diane, quick, turn on the TV. Your thesis building is on TV.
This is Diane Hartley.
As far as we can tell, she was the student in Lemessurier's story.
And so I, holding the baby with one arm, I fumbled for the remote and got to the channel just in time to hear.
This building could have killed tens of thousands of people.
The extraordinary chain of events began with a phone call out of the blues from a student in New Jersey whose professor had told him to write a paper on the Citicorp Tower, William LeMessurier.
And I explained to the student in the telephone call that he could tell his professor.
I was aghast. I nearly dropped my baby.
This was the first time Diane had ever heard of the emergency retrofits, the round-the-clock weather monitoring, the evacuation plans.
And the involvement of a student.
So when she heard LeMessurier reference a student, a male student...
I, of course, assumed, gosh, there was some guy studying the building as well. And wow, how could I miss this? Wow. So it was pretty remarkable. But I, of course, assumed at the time that there was another fellow who had been a better researcher than I had been.
In fact, Diane never even considered that she might be the student in the story. That is, until she went to a Princeton event honouring her thesis advisor, David Billington.
When I showed up at the event, David said, well, have you ever heard of the problems with the Citicorp Center? And I said, yes, isn't that pretty remarkable? I wonder who it was that discovered this problem. And he said, Diane, there are very few engineering schools in New Jersey. And quite frankly, I know all of them. And I know the heads of the programs of all of them. And I've talked to all of them. There was no other student from New Jersey that was studying the building except for you. So it must have been you.
Yes, I don't know about any other student.
This is David Billington, the thesis advisor.
Yes, my name is David Billington, that's correct. And I'm an engineer, spent 53 years at Princeton as a faculty member. I was Diane Hartley's thesis advisor. She wrote the most outstanding thesis of anybody. It was a very long, have you ever seen it? 2 big volumes, yes. Anyway.
To hear Diane Hartley and David Billington tell the story, Diane wasn't some in-your-face know-it-all.
Here's her version of the events.
So I was 21 years old, and I was a senior at Princeton University where I was studying architecture and urban planning. My thesis, I had selected the topic of the Citicorp Center in New York, which had only recently been completed and occupied.
She reached out to LeMessurier's firm to get the calculations that they had run. And then she tried to replicate the math herself, to do the work again from the start and see if she got the same answers as LeMessurier's engineers. David Billington, her advisor, asked her to ask LeMessurier's firm about the quartering winds.
The quartering wind, I thought that was a problem and that it should be looked at.
So I obtained calculations from the design engineer from LeMessurier's office, and I concluded the governing loading condition was the wind hitting the corner of the building.
But the math just wasn't coming out right.
I was struggling with the calculations. I assumed, of course, that the engineer had done the right thing and any inconsistency that I might find would be my error. The building was standing.
After all, she was just a college senior, and LeMessurier and his people were established, internationally renowned, professional structural engineers.
Diane got back in touch with LeMessurier's firm, although she never talked with LeMessurier herself.
I never called LeMessurier. I never said these things that were documented in the various reports that had been published to date.
Diane did talk to a junior engineer at LeMessurier's New York office named Joel Weinstein. She showed him her calculations.
But at the end of the day, no, I didn't feel that I had put my finger on a major problem. I assumed I was wrong and wasn't understanding things.
Even David Billington, who had told Diane to look into the quartering winds in the first place, didn't think there was any imminent threat.
I mean, I don't think either of us really were in a position to say at the time, you've got to do something, Bill, right away. We didn't have that feeling. I had the feeling that she should talk to the designers and find out whether this quartering wind had been considered, and if so, what was the outcome.
But somehow Diane's discovery got silently passed up the totem pole within LeMessurier's firm.
Weinstein must have said, well, I better check with Bill. That would have been the logical thing to do, and he probably did that. I never heard that. You never heard it, I guess.
We asked Joel Weinstein, the engineer, about meeting Diane and what happened afterwards, but he says he has no memory of this either way. Though he does acknowledge that if Diane remembers speaking to him, then it probably happened. And that in such a circumstance, he would have passed her message on to Lemessurier.
So it could be that's why Lemessurier remembers speaking to a male student. He was conflating Diane Hartley, the student, with Joel Weinstein, his own staffer.
Now, of course, it is possible that there was a male student.
A third man.
Who somehow had the same data as Diane and actually did talk to Lemessurier on the phone.
But I find it really hard to believe that such a person didn't come forward and claim the spotlight after the story broke.
Gender aside, Diane definitely doesn't fit the image of the precocious student. She identified a problem without even recognising the significance of what she had done for decades.
It's not that I did something. It's that perhaps my questions helped someone figure something out. Perhaps my questions were meant to be. I think if I had really realized that there was a problem and put my finger on it and raised it up the flagpole, I could pat myself on the back for having done something that was pretty remarkable. But at the end of the day, I feel like I was a bit player in a play that had a happy ending.
So yes, she deserves more credit than she's gotten. You can tell her that. Include that, I think that's right. That's the coda for this.
"99% Invisible" was produced this week by Joel Werner and Sam Greenspan, with Katie Mingle, Avery Trufelman, and me, Roman Mars. Special thanks to Michael Verdaro, who wrote the AIA Trust white paper about Citicorp Center, Samil Raghavan at the National Academy of Engineering for helping us track down archival audio of William Lemessurier, and Alan Bellows of the website Damn Interesting for talking to me about this about 2 years ago at this point. We are a project of 91.7 local public radio KALW in San Francisco, and produced out of the offices of ArcSign, a beautiful architecture firm in beautiful downtown Oakland, California. You can keep up with this show and all the people who make this show on Facebook, Twitter, and Tumblr. But if you want to see some pictures of Citicorp Center, go to 99pi.org.
All right, and make sure you say that.
Wait, sorry, say something again?
I say this is not architecture we're talking about. This is structure, engineering structure. I'm very sensitive about that. I don't want to mix up these things. I think that in this case, Lemessurier's design was a brilliant structural design, but it was all covered over, typical of architects, to cover it over so you could never see it. Most people make that decision about tall buildings, that they want it to be architecture. And that's why most of them are so bad. But anyway, that is a prejudice. So
we'll be clear, this is structure, not architecture.
But what we're talking about is structure, not architecture.
Radiotopia.